Today we're going to talk about the diffuse life cycle. What is the diffuse life cycle? Let's paint a picture here. You send a transaction to the blockchain. Is it accepted? Is it in a block? Well, you don't know yet. What you'll get is a speculative execution from the first edge node you're talking with. It's going to try it and it's going to refuse it and tell you what happened if it did refuse it. If it accepts it, it doesn't mean that the next hop or the next producer will accept that and put it in. You might be on a blacklist, you might never see that transaction flow again, because of network issues or whatever. So it's not 100% guaranteed it'll fit in. But as a user or as a developer, you're interested in knowing if that transaction made it to the blockchain, right? You have an intent and you want to sort of have a confirmation of the commit. So how do you do that? So the Diffuse platform offers an instrumented endpoint. It's the same drop-in replacement for the push transaction endpoint from the native node EOS, except it is powered by the Diffuse platform and it listens to all the flow of traffic. And what it will do is it will submit the transaction to the network. Then it's going to start listening at the blocks produced by block producers. And if your transaction makes it into one of these blocks, we will read the execution trace and send them back to you as if they were executed by the edge node. So it's sort of a edge node on superpowers, right? And you can do that for in block. That's the small header you need to put. I want to verify if it's inside a block. But we can also do that for you and verify that it has passed the handoff from one producer to the next. What does that give you as guarantee? It means that there's less risks of micro fork. Because the micro forks often occur in a handoff from producer 1 to producer 2, this one will start producing on previous blocks because you haven't seen those ones here. Take a look at the micro forks video if you want more details. But basically, if you want to receive the traces, or you want the call to push transaction to return only when that handoff occurred and when your transaction is in the chain there, well, you can pass on handoff :1. And that will give you that higher level of certainty that the block will stick. And you can do that with handoffs :2, handoffs :3. That gives you even greater certainty that your transaction is in, and you can take sort of decisions faster, make your UI more responsive than waiting for irreversibility, for example. And you also have irreversible. That's another parameter for the header there in the push transaction call that will wait for irreversibility. So that means your REST call that calls push transaction with your transaction payload will wait until your transaction is not only in the block, but also passes the irreversibility barrier. And in that case, you can return to your UI, change it, put a big lock, padlock, do something and tell your users, congratulations, the $16 million, TV you just bought has settled in stone. Okay, that was for the push transaction. I'm going to talk about some other endpoints that give you rich lifecycle in another video.